Alright, 2018 FRQ questions 3 and 4, or 4 and 5, 5 and 6. Haha, nailed it. 2018 questions 5 and 6. During chemical reaction, function y is equal to Ft models the amount of substance present in grams. So this is an amount. At time t, at the start of the reaction, t is equal to 0. There are 10 grams. So at time 0, there's 10. So the present function satisfies the differential equation. The derivative is equal to that. So y is the amount. Okay. Y is the amount. Okay, use the line tangent to the graph of y is equal to approximate the amount of substance remaining at 2 seconds. So this is going to be a linear approximation. So what we see at time 0, as it said, at time 0, the y is 10 grams. So what I'm going to do is I'm going to first find my slope. My slope is the same thing as dy dt. And so when I have this, this is going to be negative 0.02, 10 squared, 100, so negative 2. Yeah, negative 2, and again, this is at the point 0.02, so what I'm going to first do is I'm going to write an equation for the approximation of my just the tangent line, which is an approximation. So y minus y1 is equal to mx minus x1, y minus 10, slope 0, negative 2x plus 10. Alright, so that is my linear approximation. Now what we're going to do, this should actually be t, but you get the idea. This is actually a t. The x's. So at time is equal to 2 seconds. So the amount is going to be negative 2t, which is now 2 seconds, plus 10. And so negative 4, 6. And this is an amount which is in grams. Okay, 6 grams. Alright, moving forward. Using the graph differential equation, determine whether the graph of f could resemble the following graph. Give your reason for that answer. No, we can't. Okay, so the reasoning that I kind of quickly see is dy dt is equal to negative 0.02 y squared. Let me think of this real quick. I'm just going to so the slope is negative y squared. I see that y is always positive. This is always going to be, as a result, what I see is y is always greater than 0, no matter what. Y is always greater than 0. So an amount is always greater than 0. So if y is always greater than 0, what does that say about dy dt? Well, that means that this is going to be greater than 0. It would anyways because it's squared. Thus, multiplied by a negative is always going to be less than or equal to 0, aka that cannot happen. You cannot have a positive slope. Alright, so now how to just write this, like kind of saying what I said kind of idea. Alright. Okay, since y is always greater than or equal to 0, this implies that dy dt is less than or equal to 0 because of the multiplication. So it's less than or equal to 0. So that sorry, I should probably answer the question first. Using the differential equation, determine whether the graph of f could resemble the following graph. No. Alright, sorry, no. Okay, since y is greater than 0, the dy dt is equal to that, which is less than or equal to 0, implying that the slope should always be negative. However, we see a slope that is positive on the graph. Alright, so that's the best I can do right now. Alright. Okay, find the expression y is equal to f of t by solving the equation with the, okay, so separation. So this is what I was kind of thinking about doing last time, but I'm glad I didn't. But I do have to do it now. Alright, so separation. Variable t's over here, y's over here. I'll keep the 0, 2. So I'll divide by this y squared. So this is y negative 2. I'll keep this dt. Okay, multiply the dt, divide the y squared. Integrate now. So integrate. So y negative 1 is negative 0.02 t plus the all-important c. Initial condition implies f of 0 is equal to 10. This goes into there. So that means the y is equal to 10. So this is negative 1 over 10 is equal to negative 0.02 t, which is 0. So c is equal to negative 1/10. Okay. Now plug and chug back into this equation. So negative 1 over y is equal to negative 0.02 t plus c, which is negative 1/10, 0.1. And I'm just going to do this quick and dirty. So I'm going to switch out change out. So y is equal to negative 1 over negative 0.02 t minus 1/10. You can change it up, but again, I don't want to turn a correct answer into an incorrect answer. I'm just going to stick with that and let the graders figure it out. It's all good. Yeah. T can't be negative 0.5, but I think t is assumed to be greater than 0. All right. Determine whether the amount of the substance is changing at an increasing or decreasing rate. Explain your reasoning. Is the substance changing at an increasing or decreasing rate? So what is the rate of the rate? So what is the rate of the rate? Is it changing at an increasing or a decreasing rate? Okay, so what I do know is that dy dt is equal to negative 0.02y squared. And so as a result, this is going to be d squared y dt squared negative 0.04y to the third. Alright, so y to the third. No. Jesus, where did I learn how to integrate? So dy dt. I'm sorry. Multiply down and subtracts 1. Where did I learn how to, where did I learn that? Alright, oh man, this is getting deeper and deeper, which is negative 0.04y dy dt is negative 0.02y squared, leaving this to be a positive 0.0008y to the third. Yeah, 4 decimals. 2 times 4 is 8. 4 decimals, y to the third. And so y is always positive. This is always at an increasing rate. Alright? So because y is always greater than or equal to 0, so the amount is always greater than 0, that implies that d squared y dt squared, alright, the second derivative, the rate of the rate, okay, this is always positive, this is always going to be positive. So it's always greater than or equal to 0, which implies that this is at an increasing rate. Yeah, boy. Alright, number 6. Consider the curve, etc., 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 given by the equation for all points. Okay, 2/3 to 2. Show that dy dx is equal to that. Okay, so it looks like just take a derivative of this. So let's go with 2x minus y, 3 plus cosine y. So we're taking this with respect to x. So that means whenever we take a derivative of x, that's cool. However, whenever we take a derivative of y, you have to add a dy dx. So I'm just going to make this a little bit easier on myself with that side right there. And away we go. So 2x is 2 minus 2 dy dx, because we took a derivative of that. 3 goes away, cosine goes to negative sine. Chain rule on that, dy dx. Get all the dy dx's to one side. I'm kind of taking this, so I'll keep the sign negative, so I'll move the 2 over here. So this will be a positive 2 dy dx minus sine y dy dx, so kind of GCFing out the dy dx is equal to that 2 right there. Divide it out. So 2 minus sine y, it's all denominator of that 2 dy dx. There it is. Okay, so there it is. Okay, for 0 to, negative pi over 2 to pi over 2, there's a point P on the curve which the tangent line has a slope of 1. Find the coordinates of that P. Okay, so they're just kind of referring to, so the slope is equal to 1. So where the heck is the slope equal to 1? Alright, so let's just see if we can do this algebraically here. Minus 2. Negative 1. And so coordinate, where is there a sign, aka the y coordinate equal to 0, right there and right there. And so we're at 0 and pi, but we're looking for the stipulation that it's actually between negative half and positive half, so it has to be there. So y is equal to 0. Okay, so the coordinate. Okay, so the coordinate, so the y is equal to 0. So y is equal to 0. And then what I would probably assume is I have to put it back into this equation right up here. Yeah, the actual equation. So the actual equation. So 2x minus y is equal to 3 plus cosine y. Okay, cosine, so this is at the coordinate 1, 0. The cosine is equal to 1. So this is 3 plus 1. This is 2x. So we have an x coordinate of 2 and a y coordinate of 0. So what are the coordinates of that point P? Point P is equal to 2, 0. Alright, question C. Okay, determine the concavity of the curve at point. Okay, so what is the concavity of that range? So that is the second derivative. So what I'm going to do is I'm going to take my first derivative, and take the second derivative. Alright, this is going to be a little sloppy, but here we go. So d squared y dx squared, so take care of that negative 1. Chain rule. So 2 goes away, sine goes to cosine. Chain rule on that. Okay. So let's see here, plugging in the dy dx. Let's see, negative 2 minus sine y squared times negative cosine y times dy dx. That's to the first power. So this needs an additional, so good gravy. Let's just say that this is 4 cosine y, 2 minus sine y, no, I can just multiply. Duh, I'm an idiot here. 2 minus sine y to the third. I think something like that. Yep. Alright, yeah, sorry about that misdirection. can just multiply, not a big deal. Alright, so what is the concavity in that range? And so what we see from this is, okay, sine's always going to be less than or equal to 1, so this is not even possible for this to be a negative. So this is always positive. That is always positive. So sine is always going to be small. And then if we're talking from negative pi over 2 to pi over 2, cosine, the x-coordinate is always positive. So this is always positive, implying that this is always positive. The numerator is always positive, so we see that d squared y dx squared is greater than 0. So this implies that this is always positive concavity, concave up. Again, this is very specifically negative pi over 2, pi over 2. This is always concave up. Okay. Alright. Last but not least, we'll let y be the function and define implicitly by what it continuous closed interval. Okay, sorry, I'm misreading this. Continuous on the closed interval. Okay, okay, so it's okay, closed. And then differentiable, and again, this is a crazy, okay, so continuous and differentiable. Alright, so that's all good. Use the mean value theorem. Okay, so yeah, so we can use the mean value theorem. Show that okay. Okay, so mean value theorem. ARC is equal to IRC, or IRC is, oh, flip-flop it. So f prime of C, there is some point C that is equal to the slope old school style. So the f of 2.1 minus f of 2 all over 2.1 minus 2. So that is the mean value theorem. So f of 2.1 minus f of 2 divided by 0.1 is that. So have to think about this just for a second here. So what I'm trying to think of, like, how do I establish a range of this slope right here? Oh, aha, haha. It's my overlooked piece that I always they said that for a reason, and that's where it is. Okay, I figured it out. So this slope, okay, this slope is drop down. So this is saying that f of 2.1 minus f of 2, the slope, okay, the slope is in between 2/3 and 2, so multiply that out. So that's in essence like a multiply by 0.1, or aka 1/10. So this would be 2/30ths. I thought I was going to be stuck there for a second. And this would be 2/10. So aka 1/15. 1/5. Huzzah.